Welcome back to A Story of Ratios. We are on Module 1, Lesson 2 in the ratios and proportional relationships module. This Lesson 2 continues on this idea of proportional relationships. And again, this idea of proportional, we will see it as we work through this lesson more clearly. But this idea of proportional is if you're trying to find two quantities that are proportional, and the only way they're proportional when we talk about ratios or unit rate or rates, etc., is when you can multiply the same number by both of those quantities to get the new quantity. And I know it sounds a little bit confusing. I don't want to write anything down yet, but let's just start off with this problem. Pay by the ounce frozen yogurt. You should be in your binders, and this is the page you should be starting on. Have a pencil with you so you can take some notes, do some calculations. If you don't have one, just stop this presentation and go get all your stuff and come on back. Okay. So here we are. Let me go ahead and read this example one. Paid by the ounce frozen yogurt. A new self-serve frozen yogurt store opened this summer that sells its yogurt at a price based upon the total weight of the yogurt and its toppings in a dish. Each member of Isabel's family weighed their dish, and this is what they found. Determine if the cost is proportional to the weight. Okay, if you would go ahead and pause the presentation here, and let me go back up to where we were, and go ahead and work on Isabel and her family and her price per ounce, which is what we're going to come up with, and then come on back after you're done. Okay, yeah. Hopefully you saw a pattern, and that's pretty much what we're looking for if we're going to look for something to be proportional. We're trying to determine if cost is proportional to weight in these scenarios. And let's again just make it clear that we're talking about like four different people here. Okay, so person one, person two, person three, person four. Okay, and these are the different scenarios here. So person one bought 12.5 ounces of yogurt for $5. Person two bought 10 ounces of yogurt for $4. Person three bought 5 ounces of yogurt for $2. Person four bought 8 ounces of yogurt for $3.20. Now, every one here, well, three of them are somewhat clear if you're going to do the division, because division is what you need to do. Because whenever we talk about, we're doing cost per weight, so we're actually doing price, in this case, per ounce. Okay? Price per ounce. So 10 divided by 4, or I'm sorry, 4 divided by 10 is pretty clearly 40 cents. So 40 cents per ounce. Okay, 40 cents per ounce. Now, if we take the next scenario, scenario number 3, very interesting. If you look at both the weight and the cost and compare them to scenario number 2, you will see that there is a relationship here. Okay, 5 times 2 is 10, 2 times 2 is 4. So if you see a relationship like that, you know it's going to be proportional. And if you did the math as well, you would see that it was also 40 cents an ounce. Okay, 40 cents an ounce. Scenario number 4, again, $3.20. You see that 32 in there. You see the 8. If you know your fact families, there's a 4 plays a part in there. In this case, it's less than $1. So it's going to be 40 cents an ounce as well. And yes, if you do the math and divided $5 by 12.5 ounces, you would get 40 cents an ounce. So yes, if you come up with that answer, they are indeed proportional. So we say cost is proportional to the weight across the different scenarios. Now let's throw something else in here though. Let's add someone, and let's say Isabel's brother. He was taking his time, wasn't quite ready when it came. They got to the cash register, but yeah, he did come. He did come back, and he bought 15 whopping ounces of yogurt and toppings. Okay, what I want you to do is I want you to use this pattern, use this price per ounce, and calculate what the cost of his yogurt and toppings was. So I'm going to go ahead and pause again. Okay, yeah, so we're back. All of my data has been wiped off the face of my page here, but let's go ahead and figure this out for Isabel's slow brother here. Slow in the sense that I'm just a hungry brother, let's say. Okay, so we said he had 15 whopping ounces of yogurt and toppings, and our rate we came to was 40 cents per ounce. So if you went ahead and did when we were figuring out our price per ounce here, we were using a division. Okay, we were dividing. Now, hopefully you noticed that we had 15 ounces here. We needed to go ahead and multiply by our price per ounce to come up with $6. Okay, so they paid $6 for the brothers' 15 ounces of yogurt. Hopefully you could see if there was any hesitation at all, you could see that here we had 12.5 ounces of yogurt. Here was $5, so you knew it had to be higher than 5, and not much higher. Okay, but again, just applying that proportional relationship or that unit rate makes life much easier. Okay, so we're going to go ahead and go down and look at this one here, a cooking cheat sheet, and I want you to go ahead and just take a look at this for a minute, and I want you to see if you see a pattern or see what's going on in this, and I'll be back. Well, as you could see in this diagram, this easy conversion diagram found in the back of a recipe book, and many do have a diagram similar to this. You would notice that it's just actually giving us the conversions, converting from cups to ounces, or ounces to cups. And what you come to see is that for every 1 cup, we have 8 ounces. Okay, so that is the basis of this diagram. It's kind of its origin in a sense. 1 cup, 8 ounces, because you'll see as you move up a half a cup, you go up 4 ounces. 4, of course, is half of 8, and up here 2 cups, 16 ounces. Again, 2 times 8 is 16. In fact, you can multiply all of these. If you multiplied 1/2 times 8, we do it that way. See, we would get 8 over 2, and we would get 4, and that's the answer right here. Okay. So what you're doing as you move across, you're just multiplying the number of cups times the number 8. Okay. Yes, and hopefully that's something all of you knew. But let's go ahead and apply this. Let's go ahead and apply. I want you to do some figuring for me, and I won't give you any time to do this. I think this is going to be relatively easy for most of you. But tell me, how many ounces are there in 4 cups? Okay, so you have 4 cups. 4 cups would be, if you apply the rule, 4 cups, and you have 8 ounces, and that equals 32 ounces, okay? So we have 4 eighths, 32, okay? And then if we had 5 cups, what's that? 5 times 8, that would be 40. On and on and on. How about 8 cups? 8 times 8, who knows their multiplication table? 64 ounces in that case, okay? So yeah, so it gives us, it gives us a way to quickly go to the back of the book and see a conversion really quickly. But what we need to see is we need to see this idea of proportionality, and let's see how it fits algorithmically. Okay, so if we were to write this down as an algebraically, we would go ahead and do this. Let's just go ahead and start using some variables here. Okay, so if we looked at y, we could use the letter y. Okay, and y, we're going to have y represent the number of ounces. Okay, that represents the number of ounces is y. Okay, number of ounces. So for any given y equals 8x. So the x, as you can imagine, would be what? Or what would you imagine the x would stand for there? If the y is number of ounces, 8x, what would the x stand for? Well, that's right. If you're thinking cups, you would be right. Then all we'd have to do now in this case is plug in some numbers. Okay, and if we took from the top here, for example, we said 16 was number of ounces. 16 equals 8 times 2, which equals 16 as well. Okay, all right. So we can see how we can start applying some algebra to all of this. Okay, it's always good to test an equation, because that's what we've created. We created an equation when we looked at y equals 8x. So it's good to test that equation with a number of variables here. So let's go ahead and plug in a couple of values here from our chart. We already worked with 16 and 2. How about 12? Okay. So 12 is our y. Okay, so we're saying 12 equals 8 times, let's say 1.5 or 1.5, 1.5. And if we did that, 8 times 1.5, 8 times the 1 is 8, 8 times a half is 4, and that equals 12 as well. Okay, so that works. All right, so you can apply it. How about those zeros over here? Those zeros, let's apply that. We have our y as 0 equals 8 times 0 as our cups there, and 0 equals 0, and that works. Okay, I would like you guys to take about 5 minutes, or a little bit more if you need it, of course, to go ahead and complete the following example independently, and then go ahead and we'll come back and we'll discuss it with you. Though discussing with someone on the other side of the computer is a little bit difficult, but I'll go ahead and explain the problems or explain the example. So would you go ahead and do those exercises, and and come on back. So I'm confident everyone was successful with this exercise. Okay, so question A just asked, is the number of calories burned proportional to time? How do you know? And if you went ahead and looked at that chart, um, you can see 1 minute, 11 calories burned, 222, 333, 444. Of course, yes, indeed. It was proportional. So for every minute of time, 11 calories were burned. So 11 calories, per minute. Say was our rate. Okay, for that. B went ahead and asked for okay, there. B went ahead and asked if Jose jumped rope for 6.5 minutes, how many calories would he expect to burn? Okay, and by using our rate of 11 calories per minute, multiplying 11 times 6.5 would give us an answer of 71.5. 71.5 calories in 6.5 minutes. Okay? Alrighty. So that is that. Now we have example 3 here. And this is a summer job. And I don't know if many or any of you have summer jobs. You are pretty young yet, but I know as a young boy, I worked for my dad in his bakery shop. I grew up on the East Coast, in New Jersey, and if any of you know, but I was pretty much born and raised in that bakery shop. Actually, it started in 1961. My dad opened it up, and that's the year I was born. So I used to work for him. I used to get like $5 an hour. I remember, it's a long time ago too. My dad paid me pretty well. Worked on weekends. But yeah, I don't know if you guys have summer jobs. Maybe some of you do work for your parents as well. But we're going to talk about Alex here. Alex spent the summer helping out his family's business. Ooh, like me. He was hoping to earn enough money to buy a new $220 gaming system by the end of the summer. Halfway through the summer, after working for 4 weeks, he had earned $112. So Alex wonders, if I continue to work and earn money at this rate, will I have enough money to buy the gaming system by the end of summer? Okay, and let's see, a key thing Alex has mentioned in here, at this rate. So that might tell you, hey, I need to uncover a rate. Okay, so to determine if he will earn enough money, he decided to make a table. Very good idea. Tables are very good. He entered his total money earned at the end of week 1 and his total money earned at the end of week 4. Okay, well, you can see down here in A, it says work with a partner to answer Alex's questions. If you want to go ahead and work either by yourself there, because you may be by yourself, or work with your mom or dad or sister or brother. Work through these problems here to answer Alex's question if he'll have enough money to buy that gaming system. And then B, are Alex's total earnings proportional to the number of weeks he worked? And how do you know? Okay, and this is something I'm trying to stress, is this idea of explaining ourselves in math. How do you know? Okay, so I'm going to go ahead and pause here, and I want you to take a few minutes to go ahead and work out those problems and come on back. Okay, so if you looking again at these questions here, answering Alex's question, and of course, again, his question was, will he have enough money to buy the gaming system by the end of the summer? Okay, and this example kind of really gives you the answer right away. Kind of wish they didn't have this value in here because, as you see, if he earned $28 by the end of week one or in week one, I guess you're going to get an idea. But maybe it's a little bit of a trick. I don't know. Maybe they're seeing if you went ahead and actually took the time to do this division here, because as you can see right here, it looks like $28 a week right here. But if you went ahead and did do that and you divided $112 by 4, you would have seen that that was also $28 a week. Therefore, you could just fill in the chart. That's 56. Let's see what this one is. It's 80, 84. Adding another 28, 112, and then what do we have? 140, and then 168, and was that 196, and then 224. Okay, so the answer was yes. Yes, he would indeed have enough to buy his gaming system. Okay, and hopefully your table looks exactly like that. Now the other question, or question B, was are Alex's total earnings proportional to the number of weeks he worked? How do you know? And the answer would be yes. And of course, you know, because there exists a constant value, and that constant value is 28, and that's right here as we had circled initially. Yeah, 28. That can be multiplied by the number of weeks to determine the corresponding earnings for that week. Okay, so yes, it is indeed a proportional relationship, and that is that idea of a constant. Okay, and in this case, the constant was 28. Okay, so let's go ahead and close. We're going to close this lesson right now, and just wanted to, I'll bring it down here to the lesson summary, but of course I just mentioned it, but how do we know if two quantities are proportional to each other? And that's something I'd really like you to know. And just like I said before, if there is that constant, okay, if there is that constant, as you can see right here in the lesson summary, measures of one quantity are proportional to measures of a second quantity if there is a positive number k, so that for every measure x of the first quantity, the corresponding quantity y is given by k times x, which just sounds so darn confusing sometimes, but just like we said before, if there's this constant that you can multiply by both values or both quantities to get a second quantity, that means they are proportional, okay? A proportional relationship is one in which the measures of one quantity are proportional to the measures of the second quantity. That's right here, this idea of proportional relationship. In the example given below, just reading along here, the distance is proportional to time since each measure of distance y can be calculated by multiplying each corresponding time t by the same value 10. Okay, and this table here illustrates a proportional relationship between time t and distance y. Okay, and you can see that right here. 0 times 10 is 0, 1 times 10 is 10, 2 times 10 is 20, 3 times 10 is 30. Okay, so we have a proportional relationship there. Okay, so yeah, the rest is up to you. Do on your own. We have your problem set. Have those ready to, after you're completed those, have those ready to hand in class on the first day. And also don't forget to do your exit ticket. We will take a look at those in class. And yeah, so I hope all this was as easy as I think it probably was. If not, you could always call or email me with questions. So good luck with the problem set, and see you again for lesson 3.